and so one kid gave me a sign up. Okay, so I'm going to try to keep it clean today so they don't ban me. All right, so let's go ahead and look. All right, guys, now we talked about, let me just show you here. We talked about the law of, the impulse momentum theorem. All right, let's make sure we're on track here. And we said that Ft is equal to m delta v. Let's just kind of quickly go through this. Ft is m delta mv. Remember, that's final minus initial, okay? So, moving right along, and I'll take roll at the end. We're going to deal with that later. I just want to get this in for you guys. And really, I want to really kind of pack a lot in today, that if we're actually in tomorrow, you'll probably just work on homework tomorrow during class. If we're out tomorrow, you need, I'm just telling you because this is an AP class, you need to spend an hour working on homework tomorrow. You need to spend an hour on Friday, all right? There will be some homework. I expect like a lot of it to be done, but I'm going to coordinate, tell you like starting with the easiest, work on the harder stuff, maybe give you some answers today to some of it on the video so you can always write it down or whatever, watch the video, okay? But the momentum is the big thing. The law of conservation of momentum. Law of conservation of momentum basically says this. Momentum before a collision is equal to the momentum after collision. This is pretty cool. All right? The momentum before a collision, and this is the only thing I'm going to focus on today. All right? There's a lot of problems associated with it, but it's really straightforward. All right? Momentum before a collision is equal to momentum after collision. There's two types of collisions that we're going to focus on. All right? So, two types of collisions, and that is elastic, inelastic. Inelastic. What do you think that means? Elastic versus inelastic. When two things collide, what do you think elastic means? It bounces. Yeah, that's the layman's term. It bounces. Inelastic, what? It sticks. That's layman's terms. But the physics idea on is elastic is, watch this, kinetic energy is conserved. That means that the kinetic energy before the collision is equal to the kinetic energy after. Kinetic energy and inelastic, not conserved. And I'll just put that. Ke, not conserved. And we're going to talk about that in a little bit. I'm going to just do some problems. You'll grasp onto this, I guarantee you. And like I said, guys, really focus on this. I'm trying to get this in because one of the things about it is your AP exam is on a day. I mean, we don't get an extra day for it. So, like I said, at least you guys, I can record it, upload it. You guys will get it. If you do what I tell you, there's really not going to be much loss the next 2 days. All right, so let's look on it. Let me give you an example. Here, this is a train. Don't laugh, okay? This is a train. Or now let's just say, I don't know, an object moving. This is 5 because a 5 kilogram train's not that big. Moving at 3 meters per second, collides inelastically with another object that's 4 kilograms at rest. They stick together. They stick together. They become one unit. What is the new velocity? What? Isn't it
1.5 here?
I'm not done. I need to set it up. Don't give me an answer. You were giving me an answer without setting it up. Hold on, partner. I don't know. I just made it up. You could be right. So what do we do? Okay, By the way, momentum is conserved. One idea, guys. That's all we're talking about. One idea. Hang with me as we go on this one idea. One idea is all it is. Momentum is conserved. In other words, before a collision and after a collision, okay? So watch. 5 times 3 plus 4 times 0 is equal to, since they stick together, they're like one unit. So I have 9v, the new velocity. So what do I have? 15 plus 0 is equal to 9v. What does v equal to?
15 over 9.
Oh, yeah, well, thank you for that. How about reduced into decimal form?
1.66 or 1.
Okay, 1.67 meters per second. Did you tell me, is that what you gave me?
I said 1.5.
Okay, yeah, don't do that. Follow what I'm doing. I want to see your work, okay? Now watch. This is inelastic. Let's do a few more. How about this? I'm going to put a couple up on the board, and I want you to try them. And then we're going to do them together.
Yay!
So, this one collides. This one is 5 kilograms going at 3 meters per second. This is 3 kilograms going this way at 6 meters per second. They collide inelastically. All right? They collide inelastically, which means they what? Stick together. Inelastic collision. One idea. One idea. And I'm going to take roll. You're going to work it. All right, Olivia, what'd you get?
I got -0.375.
You got a negative?
Yeah?
Well, let's see what Olivia did. Did I get negative, like Olivia? Did you get Olivia's answer? Yay, Olivia! So watch. 5 times 3. Olivia, read the next part off to me. Go.
Oh, plus 3 times -6
Is equal to what?
is
8v. Now watch. 15 minus 18 is equal to 8v. Negative 3 is equal to 8v. So what's v equal to? What'd you say?
-0.375.
0.37?
5, yeah.
How about 0.38?
Yeah.
Negative 0.38 meters per second. Now Olivia, you're on a roll. What does that negative tell me? Gosh, a bunch of Olivias are here.
Yeah.
Okay, Olivia.
Direction?
See,
Maybe?
these guys are having to help her out. Now that's mansplaining.
They're trying to help women instead.
Jeez,
I'm
Olivia,
need
you're
more
doing fine.
feminists.
Olivia, you've heard of mansplaining?
No. Why not?
Don't worry about it. You're doing well. Jeez,
Okay.
this is on video too.
Another
Go.
strike.
Direction?
It's a direction. It's acting to the left. Okay? Now, let's see this. This is the whole idea why semi-trucks, one of the reasons why semi-trucks, years ago, semi-trucks, on the interstate, cars could go 70, semis were 55. Okay? The idea was based off of physics because, have you ever seen a semi hit something? It destroys it. It's gone. I mean, it's obliterated. It's forever gone. Okay? But the idea was this. What is a way to, I mean, when it comes to collisions, momentum is everything. Momentum and kinetic energy. So what do they want to try to do? Like in an accident, they want to lower the momentum in accidents. So what are ways to lower momentum in an accident? Lower the what? Velocity or Mass is not really likely, so what would they do? They tried to slow the semis down. So we're going to have them to go at 55 miles per hour, because if they collide with something, it's not going to produce any damage. I'm sorry, will not have the damage. The problem is that semis are so much bigger than a car, okay? So dropping at 15 miles per hour didn't help, because here was why. Physics-wise, great idea. Less momentum on a semi. Here was the problem. They did a study that said that anytime vehicles, when there was a disparity of mph, miles per hour speed limit, there were more accidents. So they saw that there were more accidents when semis were to go 55 and cars to go 70. Either keep them all at 55, keep them all at 60, keep them all at 70, regardless, keep them all the same. So while physics it was right, they found out due to research there were more accidents because of the bigger difference. Does that make sense? So that's where the semis were 55. Here's where it used to be. 55 for everybody, cars 65, semis 55. Then I think the governor signed into law, both of them at 70. So we were the longest time, 55, 65, maybe at 55, even 70 for a while. But eventually they had semis the same speed. Because again, they saw there was more accidents because of the difference in speed, okay? So, but let's turn this out around a little bit. Let's suppose two things collide with each other elastically. And I want you to catch this, please, guys. And we're going to do some demos here on my skateboards. All right? Let's suppose we have this collides with this. 3 kilogram going at 5 meters per second this way. This is 4 kilogram at rest. They collide inelastically, which means they what? They bounce off. Are they one? No. Do they have different velocities? Yes. Watch. 3 times 5 plus 4 times 0 is equal to 3v1 plus 4v2. Ah. Look at our dilemma now. What do we have? What are we looking at? What's the problem? We have one equation, two unknowns. But what do we know?
Well, we know that in the end, 3v1 plus 4v2 has to equal the momentum, the original momentum.
Well, yeah, but you still have two unknowns.
Yeah, but the thing is, you can adjust the unknowns, but when they collide, one might like keep some of the momentum while the other doesn't.
Yeah, but you don't know. So here's the problem. You have one equation, two unknowns. But what was the definition, the physics definition of an elastic collision? Kinetic energy is conserved. Watch this. 1/2 times 3 times 5 squared plus 1/2 times 4 times 0 squared. And I'm going to give you some good news on this. Ah, look. 2 equations, 2 unknowns. Can we solve? So you, my algebra whizzes? Who's the algebra whiz here? Dave, are you the algebra man? What math are you in, Dave? Algebra 2? Who's in pre-calc? Okay. Is this going to take a little while to solve? This is going to take a while to solve, and the reason why is the V1 squared and the V2 squared creates what? Either a circle or an ellipse. So you have a circle with a line going through this. There's a possible of a couple solutions, but you have to eliminate those when you look at them. Now, here's the good news. When I was in college, back in the 80s in physics, This was actually in college, this was the problem. This was a problem on my college. You guys are juniors, all right? Look at what you're learning here. You're learning stuff that I learned in college now. We had to solve, but let me ask you this. Beyond this, what physics is there beyond what I've got set up here? Think about it.
I mean, you know,
The rest of it is what? What? Algebra. All right? Here's what we do. Whenever you encounter one of these, just write the two equations and I will settle with you on that. You do not have to solve. All right? You do not have to solve. Now, sometimes they will tell you what the second one is. Okay? Then you can solve. But for now, if they don't tell you one of the velocities after the collision, okay, you got to do that second equation. So right here is your solution. Does that make sense? All right. Let's do something else. Wow. Guys, we're going to try to go, I'm not going to take, I just really, I know, I don't like to spend 45 to 50 minutes pounding stuff into you, but we're rehashing the same thing again. No harm, no foul if we're in. I'm really more concerned if we're out this afternoon, get that information, but I've told the afternoon, this video and all that stuff, they can do it themselves, okay? So, what would happen, okay, David, how much do you weigh? 130? Anybody weigh less than 130? What do you weigh? 118. Anybody weigh less than 118? What do you weigh? 110. Okay, so we got 110 here. What do you weigh?
Like 145.
What do you?
160.
Anybody weigh more than 160? What do you weigh?
Like 170.
Okay, so here's the deal. Okay, go get my two. Can I have your help here, Amir? I want to have you to handle the video and turn it and make sure that they can see this. All right, I want you to see something. Well, we get the two out. Now, all right, so if they look at who potentially has the most momentum here if the velocities were the same. Because he weighs more. Okay, so here's what I want you to do. Let's put them on the ground. All right, what I want, okay, I want you, all right, now you be in front, you're the lighter one, 118, you face that way. All right, cross your legs there. All right, you're going to sit on there. And what you're going to do is push off. Now watch this. Watch what happens. Law of conservation of momentum. Get it right up on him. And what you're going to do is push off from him as hard as you can. But wait, just watch. Let's predict what's going to happen. Heavy dude, light dude. Okay? Now, let's predict. You learned the law of conservation law of conservation of momentum is in play. All the time. 100% of the time. It's always in effect 100. Always. You know, they always say always is rarely happens. That is true. In this case, it's always. Any type. But shoving off conservation of momentum is in play. So can you push off really hard and watch what happens? Go. Ah! He had what? The greater what? Because he had less. What can we say about the momentum of each? They're the same. He has more mass, less velocity, more mass, less velocity, and then what happened? The momentum was the same, right? Or maybe because the heavy dude was behind. You go to the front. You're going to push off now. Let's see if my theory holds true. All right. All right. Light dude going to push on heavy dude. Hold on. Get real close. Now, do you suspect the same thing's going to happen? That heavy dude's going to go less speed? Let's check on. Okay, light and heavy dude. Okay. Well, one thing is, you probably need to meet me at Planet Fitness here sometime, okay, after school. So you are invited, I can bring a guest, okay? So let's try this again. Okay, what happened to light dude? He went farther, right? Well, now wait. Okay, so I need to find two people who are the same. Matt, what do you weigh?
140.
Who's 140-ish?
I'm 150, he's 145.
Okay, okay, get over here. Sit here. What do you suspect? What do you suspect? Two normal dudes, same weight dudes. I use dudes very loosely here, okay? All right, same mass, very similar mass. What do you suspect? They're going to be the same velocity. Get up there and push. Go. They look pretty close, right? All right. I want you to stay right there. Stop. You stay right there. Now, that was pushing off. So is it safe to say momentum that way is equal to momentum that way? Yeah. You know the other way you could do this? Before they shoved off, what was his momentum before they shoved off? Plus 0 is equal to mv plus mv. Okay? We're going to do some problems. But now let's do a collision. Look at your homework, or what we did on the problem. Have you noticed when people collided with each other or out there, what happened to the velocity when they actually stuck together? What happened? When they coupled means they stick. Then what? They slow down. Okay, what I'm going to have you to do, all right, is grab him in the shoulder here. Can you get up there? Can you cross your feet? Wrestler dude, let's see how limber he is. Okay. Ready? All right. So no, I'm going to shove you into him. All right?
Yeah.
So I want you to grab onto him. What do you predict? No, don't shove him. I want you to grab a hold of him. They're going to inelastic together, right? What do you think will happen to their velocity? He will move. What do you think will happen to the overall velocity compared to first dude here? What? At the end. Here we go. All right. I don't want you to shove him. I want you to grab him. Ready? He tried to grab him as much as he could. What happened when they collided and stuck together? What happened? They slowed down, right? Because you got to understand this. He was going fast. He was not going. But now he's moving. A little bit of that energy in him went to him. But ultimately what? But the momentum before is equal to momentum. Okay, give it up for these guys, okay? All right, put it up. All right, turn this around. Let's face the board. Now, you might run into this problem. Watchy, watchy. This collides with this. I'm going to give you several scenarios, okay? This collides with this. 5 kilogram here going 3 meters per second. 4 kilogram at rest. Collide. The first one is actually going 1 meter per second. All right? This is an elastic collision, but I just happen to give you one of the velocities post-collision. All right? Watchy, watchy. So, somebody want to read me an equation? Amira, lay it on here. I'll help you out. 5.
5. Okay. Wait, we're writing the oh. Okay. 5 times 3 plus 4 times 0 is equal to 5 times 1 plus 4. That's at rest. Oh. Okay.
No, that's
Oh,
that,
we
we
don't
want to know the
want
velocity
the
of that one.
Okay.
Now we can solve, right? This is an elastic collision, right? Right? Yeah. All right. What you guys get for V?
I got 2.5.
V is equal to what?
2.5 meters per second.
Anybody get 2.5? Yeah. 2.5 meters per second. Yeah. Okay? Everybody catching the drift here?
Yes.
I'm not
sir.
working any of the examples in the book at this time. Here's another one. I want you to work this, and then maybe we'll look at an example.
Okay.
A boy and a girl.
Yay.
They push off on a frictionless surface. Okay, so the boy, girl, the boy is 50 kilo, what'd you say? They're on skates.
Oh, okay. Well, like, who shoves the other person?
Yeah.
Who's
What?
the aggressor in this situation?
Oh, okay.
The woman.
50, the boy is 50 kilograms, the girl is 60 kilograms.
What?
You want equality, don't you?
Wow. No, she just been hitting
Oh,
the gym.
so, okay.
That's 10 more
Oh.
kilos of muscle.
I am trying to be fair and treat everybody with equality here. All right, the next problem, I'll make the boy heavier, okay?
Yeah.
Good Lord, I'm
It's
telling
10,
you.
it's 10 kilos of muscle. That's what
Okay,
it is.
yeah, the girl's a weightlifter.
Yeah. It's like me and
Did
Ryder.
that really set you off, huh?
Yeah.
I was waiting for one person to say something.
Wow.
And I was waiting for you to mouth off on
Wow.
that one.
There's another strike. There's another strike.
Yeah.
Your channel's gone.
Yeah, I don't know. Yeah, I'll have to do another burner. Okay, here's the question. The boy pushes off. Now the question is, now listen, serious question. Does it matter if the boy pushes off or the girl pushes off?
No.
It doesn't matter. And so let's suppose the boy pushes off at 3 meters per second. What velocity is the girl going? And there's two ways to solve. I want to show you both, okay? So work on that. We're going to look at some other things. I just feel like things are so up in the air at this time, folks. So. But I'm focusing on one thing, conservation of momentum, nothing else, okay? Guys, just think, and again, don't think of, there's a gazillion type of problems that can go with conservation of momentum. There's a bunch of them. You apply the principle. Don't try to memorize, okay? Try to think here, okay, if you will. Okay, so let's take a look here. There are two ways to do this. Before they push off, there's zero. So what you could do is this. Here's I've done it both, I do it both ways. 50 times 3 is equal to 60 times V. So what do you get for V in this case?
2.5 meters per second.
What?
2.5 meters per second.
2.5?
Yeah.
All right. But this is also that because we know what? Momentum, the momentum before, or the other way is this. Before they shove off, I call it the collision, is by pushing off. Before the collision, what is the momentum here of the boy? Plus, what's the momentum of the girl before pushing off? Is equal to what? 50 times 3 plus 60 times V. The alternate way, I'm going to stop for about 30 seconds. You know what you saw? Yeah, V is equal to negative 2.5 meters per second. You might have to put to the left over here to give you direction. I want to stop. I want you to not say a word. I want you to ponder on that problem. Okay? I'm not doing that to waste time. I want to ponder what we did there, and I'll shut up. Does it make sense? Okay. All right. Now, let's, if you need a little time, just let it ponder in your brain a little bit, okay? All right. I'm trying to think of the next step. Okay. So let's pretend there's two problems here. I'm going to give you the same. Watch what I'm going to do. What did I say if you have an elastic problem and they don't give you the velocity on the right side? Just do what?
Just
Write
write
the
these.
equation.
Write the equations. Okay? And that goes the same on homework. It goes the same on your test. I just gave you a hint what you're going to have on the test. All right, I'm just going to keep it simple. Watch this. This is a 5 kilogram object going this way at 3 meters per second. This is a 2 kilogram object going this way at 4 meters per second. I want to know the velocity if they collide inelastically. Give you a couple minutes. I want to know the velocity if they collide elastically. Do I have a post-collision velocity? So you think about what you got to do there. So give you a couple minutes, guys. You're doing great. Keep doing what you're doing. You're doing awesome. You're doing great. Yeah, for you guys that need to make stuff up, if we get discombobulated, we'll work it out. I'm not gonna, you gotta get here, no, we'll figure it out. I just don't want you falling behind. That's the key. Yeah,
Also, because I wasn't here on Friday, I don't know when the lab is due, but I also have.
well, it's gonna be due tomorrow, but let's just shoot for Friday across the board.
Okay, well, I had the lab and the work we did, the homework beforehand.
Let's just wait.
Okay.
Let's just wait. I'm really trying to get by this little storm thing.
Yeah.
And then you have to understand this, I mean, yeah, under normal circumstances, you know, I'd work with you on that, but let's just, I mean, it's to your advantage, just kind of wait. I'm trying to get this stuff in. Because like I said, that's not gonna hurt you or me, give it an extra day or something.
Okay, cool, thank you.
That's your benefit, by the way. Okay, inelastic, write me an equation, Jasper.
Okay, for inelastic, I got 5 times 3 plus 2 times 4 is equal to 7.
2 times 4?
Negative 4.
And then if you did 4, you got a wrong answer.
Right. Yeah.
Right?
Yeah.
Right?
Yeah.
Hey, let's keep it going here. Is it go to what, 7b?
Yeah.
What'd you get for b here?
1.
1. Wait, did you originally, Jasper, have that
No,
as a -4?
no,
Huh?
no, I got 25 over 7.
Okay, okay, but it's okay. Make the error now, not on a test. Do you see what he did? That's good. I'm glad you made the error, so everybody will see not to make. Let's be honest, don't lie. How many forgot to put the negative up there? Okay.
Oh.
So we have another truthful one and probably have a few liars.
I'm a woman in STEM.
Did you have the negative?
I did have
Oh,
the
good for
negative.
you. Okay, good for you. Now, what I want to see, Lloyd? Yeah, you're the only one here, man. Write me what, okay, read to me what you have for this.
I have 5 times 3 plus 2 times -4 is equal to 5v1 plus...
Hold on, partner. Oh, wait, no, I'm sorry, you're doing great. Right there, is that what you had? You're done, right?
Nope.
No. What do we do?
You have to do the kinetic energy.
Yeah.
So 1/2 times 5...
Oh, good Lord.
Plus 1/2 times 2 times -4 squared is equal to 1/2 times 5v1 squared plus 1/2 2v2 squared.
All right. I tried to beat you. All right, I think that looks close. That's supposed to be a 2 at the end. If you notice, I was racing him. All right, that is 1/2 2v2 squared. That's 1/2. Okay. I think we tied. Was it even? I think we tied. Or did I beat him, or did he beat me, or tied? All right. Regardless, he was right, or I'm right. All right. Now, here's the problem. You understood the physics part, the principle. Now, nothing personal, but there's a 50-50 shot you're going to get that wrong. Okay? Because here's why. I found out when I was doing those, the longhand way, for a few years, I was getting them wrong. I did something really stupid, and probably about 20 to 25% of the time, I got it wrong. I mean, I'm smarter than you. Okay?
Maybe.
I'm joking. No, being it's like, well, geez, if I'm making that many errors, and I'm the teacher. So, and here's the deal. You're going to spend 10 minutes solving that, and you can still get it wrong. I don't want to teach you algebra. You know, do the algebra. And this is not something they would make you do on an AP exam. But right here, that's the idea, okay? Now, there is a problem in your book. There is a problem in your book that's about, I think it's the first set I gave you, was it 12? Do you know what I'm talking about? Number 12? Let me give you a hint on that one. When it bounces, it's an easy problem, but you have to do a cosine or sine in there. Okay? You have to do a sine or a cosine in there. You are only interested, oh, look, you cannot say 0.047 times 45 minus a minus 0.047 times negative 45. You are only interested in the momentum that is perpendicular to that wall. Good test question, good homework from, not saying it's on test, but it's a fair question to have on a test. You have to do what's perpendicular, okay? Everybody with me?
Yeah.
Now, here's what I'm going to do. I want, for homework, the handout. Now, I did post it on your Google Classroom, but you guys get the hard copy. There should be room for you to solve, all right? Take one and pass it. Here's what I would like for you to do. Do the handout first. That's like if we're out tomorrow, right now, if tomorrow come into class, you plop down and start with the handout first. Then do 1 through 9 and 12, the next set. And then lastly, here's the next set in the book. 16 to 21, 28 to 34. All right? So, if we are into tomorrow, you're just going to plop down and work on the handout. Now, what I'm going to do, I'm going to kill the fan because that's loud. I'm gonna give some I'm gonna quickly go over answers to the handout in the event we're out tomorrow. I wanna help you guys out, all right? So, all right, so I'm looking for it here. All right, I have to find simple momentum answers. All right, I'm gonna read these, and you just write it beside the problem. Try to do it quickly, because we're running out of time and I need to upload this. Number 1, 16 centimeters per second. See, you can leave stuff in centimeters and grams if you want. You gotta be consistent. 2, 11.2 meters per second. 3, 10.6 meters per second. 4, 340 meters per second. 5, 10.6 meters per second. 6, negative 5 meters per second, or if you say 5 meters per second west, that'd be okay. Number 7, 0.04 meters per second, he scores. I had this problem, this was one I made up like 20-some years ago, I just kind of like it. So 0.04 meters per second, he scores. Number 8, 0.22 meters per second. Number 9, 62.5 seconds. 10, there's 2 answers. Negative 0.5 meters per second, and then 0.02 meters per second. Number 11, negative 0.45 meters per second. 12, 2.7 meters per second. Does that sound okay? Let's check some book work. Like I said, if we are in tomorrow, all good, you're gonna work on the handout. All right, this book Solutions, chapter 7. I've got my mask down just to be loud enough. Did I give the answer to 2? Thought I did.
I don't think
Oh, 166 meters per second for number 2.
Uh-huh.
Number 4, 2 answers. Car A was 4,200 newtons. Car B, 5,700 newtons. Number 6, these are at a 90-degree angle, so you have to do Pythagorean's theorem. 4.24 kilogram meter per second. 4.24 kilogram meter per second. 45 degrees south of east. 8. Got a load of answers here. 8A. 240,000 newtons. B, and this is a tough one we may have to look at in class if need be. B, 4,800 newtons. C, this is a real dandy, but it's good. Stiff-legged, 240,000 newtons. Knees bent, 5,500 newtons. Number 12, 3.7 Newton times a second. Was that number 12 I gave you?
Yep.
3.7 Newton seconds. Let's just jump to 16 because I know some people have 16 done. 16 is 1.7.
No,
you only assigned 1 through 9 and 12.
we just got, yeah, we just got
Shush.
16 today, so.
He's giving us the answer.
Right, you guys are such.
You guys can be patient and wait for him to tell us later.
Okay, well,
Or if we're not here tomorrow and he can't give us the answer.
that's the deal. I'm going to try to give you the answers. I'm helping you out.
I was confused because you said, I know some people have it done.
It can be,
This is the first
You
one.
just go with it, Ethan.
it can be a surprise.
16, A is Bonzo, B is 1.7.
Bonds, okay.
18, 7.5 meters per second. Yeah. 20. Is 9.5%. That's a dandy one. 28, 3.5 meters per second. Now, if it so happens to get into an elastic and they don't give you one of the final velocities, set up the equations, okay? Actually, 29, you really can't do, I don't think. No, you can. It's a collision. All right, I'll just pause there. I can't imagine, we'll pause there, okay? This is your homework. You guys have any questions?
No, sir.
Are we good? All right.
Yes, sir.
I don't, now, you guys understand? Like I said, if we're here tomorrow, I won't want you to work on the handout, okay? We're good on that. We're gonna continue. If not, you need to spend an hour on the workout, on a handout, because, guys, it's gonna roll around and say, oh, well, okay, well, you don't have this done. It's okay. No, that's not the way. We're still gonna have our test next week, same time. That means that if you don't really work the next 2 days, it's gonna be problematic for you. Not cutting you any slack on that. Because as I said, we do not get our AP day, exam day pushed back. So, like I said, I'm trying to balance to be fair to you, okay? I'm not telling you to do 3 hours of homework tomorrow unless you want, you know. You probably will, but, because you seem to be, staying ahead. Yeah, you're behind, but you're okay. We'll work with you. No big deal. We cool, guys?
Yes.